So once again, I'm welcoming you to our discussion for today. Our video today will be focusing on the manufacture of magnesium. The manufacture of magnesium. So, what is our learning outcome? The basis of our discussion of today are as follows. In our lesson of today, we'll be identifying the processes of magnesium production, and we'll also discuss the electrolytic processes involved in the manufacture of magnesium. So let's in a meal when you want to eat, there's a main course, there's appetizer. So let's proceed to the main course. So let's talk about magnesium. Magnesium is the third most abundant structural element in the earth crust. In fact, it's the third of the metals used in construction. It is an alkaline earth metal and is silvery white or gray metal that gets dull easily on exposure to air. This image here shows us the look of magnesium metal. So, how is it produced? Magnesium can be produced by four different processes. One, the electrolysis of fused anhydrous canalite, which is a combination of potassium chloride and magnesium chloride. Then the electrolysis of fused anhydrous magnesium chloride containing fused calcium chloride and sodium chloride. The third is a carbothermal process, which involves the reduction of magnesium oxide by carbon or calcium carbide. And the fourth is fission or silicothermal process, and it also involves the reduction of magnesium oxide with silicon. Now, if we look at these four processes, we could notice that two compounds are repeated. Can you identify them? Yes, magnesium chloride and magnesium oxide. So these are the two compounds from which magnesium metal is produced, either by the thermal process or by electrolysis. But the electrolytic method is the cheapest and best method, and it's widely used today in the production of magnesium metal. But however, the cheapest is out of the compounds from which, the cheapest form is by the electrolysis of fused magnesium chloride. Now, in the production of magnesium by electrolytic process, two electrolytic cells are used, which is the Dow's electrolytic cell and another cell which is smaller in comparison to the Dow electrolytic cell. The Dow electrolytic cell is a large rectangular ceramic covered steel tank, and of course this steel tank is the electrolytic cell. Remember, in electrolysis, to carry out an electrolytic process, would need an electrolyte, the electrodes which is the cathode and the anode, and the electrolytic cell, and also a source of electricity. Electrolysis, is powered by electricity. So for the dielectrolytic cell, the cathode, which is the inner part of the cell, the anode rather, is graphite rod suspended vertically in the top of the cell. So for the cathode, it's actually the inner part of that rectangular ceramic covered steel tank that is the cathode, and the electrolyte here is magnesium chloride. Then for the other cell, it's a smaller one, like we said earlier. It's a closed top smaller cell that is also made of steel, and the cathode too is the inner surface of the steel cell, while the anode is a vertical graphite rod. So what happens in each of these is that this, like for the electrolytic cell, the molten magnesium will be liberated at the cathode, and it will now rise up to the surface and is tapped off from time to time, and chlorine gas is liberated as a byproduct. To remove the chlorine gas, it is reacted with hydrogen to form hydrochloric acid. The magnesium gotten from this cell is 99% pure, and purifying it further will be by sublimation. But we'll be talking about fused magnesium chloride, fused magnesium chloride. How do we get the fused magnesium chloride? It's actually by evaporating sea brine. That is, if the brine or seawater is rich in magnesium chloride, the brine will be concentrated by evaporating in several stages to get magnesium chloride. However, if the seawater is not that rich in brine and it's a raw material, it is treated with dolomite, which is magnesium carbonate and calcium carbonate, to be treated with dolomite, and it's now will be converted to mixed oxides. And treating with dolomite is actually by heating at a very high temperature, and then magnesium hydroxide precipitate will be formed, while calcium hydroxide will remain in solution. So when the solution is filtered, the magnesium hydroxide precipitate will be filtered off and heated to form the pure oxide, which is magnesium oxide. Now this magnesium chloride that we're talking about will be gotten from this oxide by heating that oxide, that is heating magnesia. Remove magnesia is magnesium oxide. By heating it, mixing with carbon in a stream of chlorine at a very high temperature in an electric furnace. So by doing this, we will get the fused magnesium chloride, which will then be electrolyzed to obtain pure magnesium metal, though in molten form. So we've talked about the electrolytic cells used, and we've also talked about the way the electrolytic cells are used in the manufacture of magnesium metal. So in summary, we could say that the process for the manufacture of magnesium by the electrolysis of fused magnesium chloride is in two stages. The first stage is the production of pure magnesium chloride from seawater or brine, and the electrolysis of the fused magnesium chloride obtained from seawater or brine. And we've talked about how the electrolysis will take place via the use of the electrolytic cell and the smaller cell, which is made of steel. Actually, when electric current is passed, the electrolysis will take place and chlorine gas will be evolved at the anode. I've said that earlier, but it's just like a reminder. And the magnesium metal floats to the surface and is tapped off. So that is it. But however, we can also prepare magnesium metal via electrolysis of magnesium oxide. Now the magnesium oxide is gotten by calcination, that is heating magnesium carbonate to yield the magnesium oxide and the liberation of carbon 4 oxide. So this magnesia, which is magnesium oxide, will then be dissolved in a mixture of fused fluorides of magnesium, barium and sodium in a steel tank. The steel tank now is our electrolytic cell, and then the electrolyte is the mixture of the fluorides of the elements we've mentioned. Then the cast ion is the cathode, and carbon make up the anodes. So when current is passed, the molten electrolyte forms a solid crust at the surface of the molten mass, and the molten magnesium, which is lighter, will rise up and collect below the crust, and then it taps off. So that is how we can produce magnesium chloride, or rather magnesium metal, sorry for that. So this is all we have in this video, and see you in our live class for this